Hey guys, so today's video is going to be on iron metabolism, and we're going to talk about how your body absorbs iron, what iron is used for, and what goes wrong when you have too much iron. So, what's the point of iron in the body? Iron has two main purposes in the body. The first one is that it is used as a coenzyme for a cofactor for a lot of enzymes in your body. And the second one is that it is used to produce heme. So your mitochondria take this iron molecule that you eat and they add it onto protoporphyrin 9 and then they make heme. And then heme is put into your red blood cells. And this heme is used to help bind oxygen in order to keep you alive because oxygen is needed for ATP production. So let's talk about how you absorb iron. So iron can be eaten in two different forms. There is iron 2 plus and then there's iron 3 plus. So iron 2 plus is the form of iron that is eaten with animal foods. So let's say you eat liver puree, which is rich in iron. This contains a form of iron called heme iron, which is in its ferrous state or the 2 plus state. And this iron is very easily absorbed by your intestines, so no further processing needed. But let's say you eat a plant-based food instead. So this iron is called inorganic iron. It comes from plant sources and it needs to be converted to the ferrous state from ferric in order to be absorbed by your intestine. And how this is done is in the stomach. Vitamin C as well as a low pH environment are used to help convert this 3 plus iron to 2 plus. So we have our 2 plus iron now ready to be absorbed, and it goes into the intestine from the stomach. And it is now absorbed using two main plasma membrane proteins, HFE and ferroportin. So how this works is let's say you're in the intestine and this is a cell, and this is your lumen and here's your bloodstream. HFE is on the apical portion of your cell, so let's put a little H here, and ferroportin is on the basal part. So iron comes in through HFE and enters the bloodstream via ferroportin. Alright, so now we have iron in the blood, but we have a problem because iron 2 plus or ferrous iron can't be easily transported since our main iron carrier, called transferrin, only carries 3 plus iron, ferric iron. So we have to convert it back to 3 plus. So Fe3 plus is made using a protein called ceruloplasmin. This is made by the liver using copper, and I have a video on this which I'll link in the description if you want to know how ceruloplasmin is made. But now we have Fe3 plus, and this is bound to our transferrin, or our main iron carrier. So transferrin is now going to take this iron and deposit it in your tissues all around the body. And how these tissues hold on to it is they take the iron and they put it onto a molecule called ferritin. So ferritin is our main storage molecule for iron. And in the liver, ferritin likes to clump up in groups and form a complex called hemosiderin, which is our main iron store found in the liver. So the liver is very rich in iron, and it is stored in this hemosiderin form. So let's do a quick recap. Iron is eaten in the 2 plus or 3 plus state. We can only absorb iron in the 2 plus state. So we have to convert it from 3 plus to 2 plus in the stomach using vitamin C and low pH. Then HFE and ferroportin absorb the iron in our intestine. And now it's in the blood. In the blood, it's transported by transferrin, our main iron carrier, and it's deposited into our tissues via ferritin and hemosiderin, which are our storage units for iron. So we've talked about a couple important plasma proteins, ceruloplasmin and transferrin. So ceruloplasmin is actually an alpha 2 protein, and transferrin is a beta protein, serum protein. So when you do a blood test and you look at the serum electrophoresis, you get certain peaks like this with protein groups inside of each peak. So if you see ceruloplasmin changes, you'll see changes in the alpha 2 peak. And if you see transferrin changes, you'll see changes in the beta peak. So this peak right here. So that's how a blood test can be done, and you can do electrophoresis to check on these protein levels to see if they're okay. So let's get to our clinical correlate. So let's say you have a problem with your HFE. So there's a mutation in the HFE gene, and that makes it super active. So now you absorb way more iron than you should. You have something called hereditary hemochromatosis. And this causes a lot of iron to be transported by transferrin, so transferrin is going to be very saturated, and then you're going to have elevated ferritin and hemosiderin levels in your body, which can be tested for. So sometimes they'll even do a liver biopsy just to confirm elevated hemosiderin levels. And you can do a blood test to look for serum ferritin, which is going to be elevated in the case of hereditary hemochromatosis. So this iron can deposit in various different tissues in your body and cause damage. How can it do this? Well, it creates free radicals using something called the Fenton reaction. And these free radicals damage cell membranes and DNA and a bunch of other things. So this iron likes to deposit in the following places. It likes to deposit in the pancreas, where it can destroy beta islet cells and cause diabetes. It likes to deposit in the bone marrow, so you can get anemia from this, because bone marrow is where blood is produced. It likes to deposit in the liver, obviously, because hemosiderin is right there. And these free radicals buildup can cause cirrhosis. Then it can deposit in the skin, which causes a darkening of the skin, as you can see with this hand over here on the right. And it can also deposit in the joints, which can cause arthritis and joint pain. So I hope you guys understood my little review on iron metabolism and this all made sense. If you have any questions, please leave them in the comments. I hope this video helped, and I'll see you in the next one.